9.3 Central angles. Definition 1. A central angle is an angle whose vertex is at the center of a circle. Okay, so in this circle with center C, an angle, a central angle would have a vertex right at the center. So if this was ACB, angle ACB is a central angle. I think I can write that right here. ACB is central. Get rid of that. Angle ACB is central angle. Okay, definition number 2. An arc is a piece of a circle. We've already done a little works with arc last in chapter 11. An arc is a piece of the outside of the circle. So actually it's a piece of the circumference. Of a circle. Note, we're 2 points away, always determine in one line. 2 points in a circle could describe 2 different arcs. So if this is point A and this is point B, there's 2 arcs defined by AB. One of the arcs would be from here all the way this way. This is what's commonly known as a minor arc. The other one would be from here over to here. So this is called a major arc on this side. This is a major arc. And this one over here is called a minor arc, AB, minor. So usually we need 3 points to define an arc. So if I was to put point C over here, you would know ACB would refer to the major arc. And the minor arc would just be thought of as AB. Okay, so the 3 types of arcs. One type is a major arc. And a major arc is more than 80 degrees. So a major arc is more than, 180 degrees. A minor arc is less than 180 degrees. Less than 180 degrees. And the third type of arc is a special arc, and it's exactly 180 degrees, which is called a semicircle. A semicircle is the third type of special arc, and that is equal to 180 degrees. So definition 3 is that, and I think we've already sort of figured this out, but it's that the measure of an arc is equal to its central angle. The measure of the central angle. The measure of an arc is equal to the measure of the central angle. So if we were to break out a protractor, which we don't have one here, if you were to find the measure of arc AB using a protractor, you'd actually find the measure of arc AB is approximately 63 degrees. The measure of arc ADB then would be the leftover. Well, 63 from 360 is 297 degrees. So these two we're just going to take as given. So now, let's suppose that C is the center of the circle to the right, is the measure of the central angle. And what we're going to do here is find the measure of arc BD. How we're going to do that is, well, by definition, arc BD has to be 73 degrees because it's the same thing as the measure of the central angle. Arc AD, which is the leftover from 180, has to be 107, right? Because 107 and 73 will give me the whole 180. And arc ABD is going to be 180 plus this leftover, 253. Find the angle CDB, and no, it's not a typo. So let's go ahead and drop a line, a straight line from D to B. We want to find the measure of angle CDB, which is this angle. Well, let's think about the construction here. This isn't a radius, so CD has a value, and BC is also a radius, so BC has the same value. So this is really an isosceles triangle that has a vertex of angle 73. A vertex angle of 73. So if you do the math out, if you take 180 minus 73 and divide that answer by 2, you'll get each of these base angles, and that answer is 53.5. Again, your classwork is on the next page, and I'd just like you to do tonight, please just do 9.3 classwork, which is the next page. Just do number 1, which has a lot of parts in it. There's like, it goes A through I. Do number 1, A through I on the next page for class. And see you next class.